Hey guys, here we have a review of scientific notation. Scientific notation is something you guys learned in 6th grade, and it is a way to write really, really big or really, really small numbers. In the big scheme of things, mathematicians are lazy, so they decided that using powers of 10, they can create shorter versions of long numbers. The rules for scientific notation are simple and sweet. To be in proper scientific notation, the number must be written with a number between 1 and 10 and multiplied by a number of 10. So here we have 23 times 10 to the 5th, and it is not in proper scientific notation. Review the rules and discover why this is not the case. So, in this sense of words, we have a very large number, 137, 0, 0, 0, 0, 0, 0. And it can be written as 1.37 times 10 to the 8th because we have moved 8 places. So now take a moment to pause and use scientific notation to write the following numbers. Awesome. Hopefully you guys are back, and here is your answers. The first one would be 3.47 times 10 to the 5th, 9 and 2 100ths times 10 to the 8th, and 6 and 14 100ths times 10 to the 4th. So now we're going to go the other way, and to convert these we need to know how many places we're moving. This is where it's really important to discover if our scientific notation has a positive or a negative exponent. Exponents are what you guys were working on before this, so you should know the difference between positive and negative. Here we have 1 and 23 100ths times 10 to the 5th power. And so if we do that, we're going to move our decimal 5 places, which would give us 123,000. Here we have 6 and 806 thousands times 10 to the 6th. Moving that, we will arrive at 6806000. Here are some more examples for you guys. Like I said, this is a review, so just giving you quite a few examples to practice. The first one we are going to convert to exponential form. To do that, we must discover where the decimal will be, and if we can't see it, it is always at the end. So our decimal is at the end. We need to move it to get a number between 1 and 10, and we will move it 3 places to the left, which results in a positive 10 cubed. The next example we have is scientific notation. We're going to change it back. So we have 2 and 48 hundredths times 10 cubed. We are moving our decimal 3 places, and we will arrive at 2,480. Here are the answers for the last two. So in the United States, there are 15 Sorry guys. We have some households that use private wells for their water supply, and we want to write this number in scientific notation. So to write it in scientific notation, we are going to move to where we have a number between 1 and 10. So we're going to move our decimal to between the 1 and 5, and then count our place values. So we have 7 place values. So we have 1.5 times 10 to the 7th. So a little personal information for you guys to know is that I have 2 dogs, if you haven't figured this out already. They are both types of collies. The U.S. has a total of 1 and 1.2916 times 10 to the 7th acres of land reserved for state parks, and we want to write this in standard form. So to do so, we're going to move our decimal place 7 times. And we have 12,916,000 acres for state parks. So these are just examples of word problems that you guys might see. And one thing we need to consider is, why does a negative exponent give us a small number? If you'll look, here is a pattern that is arriving. If we have 10 to the 4th, that is going to be 10,000, and 10 to the 3rd is 1,000, 10 to the 2nd is 100, 10 to the 1 is 10, and 10 to the 0 is 1. If we were to continue in the other direction, you will see that our numbers will get smaller. So, here we have 1/10, 1/100th, which is equal to 1 over 10 squared. 1 over 10 cubed is 1,000, and 1 over 10 to the 4th is 1/10,000. When you look at these examples, this is where our negative exponents come in. 1 over 10 is 10 to the negative 1. 1/100th is 10 to the negative 2. 1/1000th is 10 to the negative 3. And 1/10,000th is 10 to the negative 4. If you have completed your exponent rules, you guys will already be familiar with the idea of taking the reciprocal when we have a negative number. So, take a moment, pause, and write the following in scientific notation. As you guys will realize, these are smaller numbers, so our exponents will be negative. The first one, we have 8 and 82/100ths times 10 to the negative 4. The second one, we have 5 and 9/10ths times 10 to the negative 7th. And lastly, we have 4 times 10 to the negative 5th. Here are some more examples, guys. Pause if you need practice. If you don't, just keep moving on. Hopefully you checked yourself and you are correct. Here we have a real life example, and so it's talking about the nucleus of a human cell, and it is about 10 times 7 times 10 to the negative 6 meters in diameter. Diameter is one of the words we're going to get to know in our vocabulary. So what is the length in standard notation? If we move it negative 6, that means we are going to make our number small, and that will give us a decimal 0.000007. Our final example here is talking about a ribosome. I'm sure I said that wrong. Another part of this cell is about 0 and 0.000000003 of a meter in diameter. So we want to write the length in scientific notation. We're going the other way. You guys want to move your decimal so that we have 3 in the ones place, and we will arrive at 3 times 10 to the negative 9.